everyone, welcome to the KVP Physics Academy. Today we are going to the start of the classical mechanics. Okay. Set Maharashtra set solution. What is the first question? The momentum of electron, rest mass is m0. In what? Which has same kinetic energy as it rest mass energy. This is the problem based on a relativistic particle. And we know that in a relativistic particle correction, gamma is equal to 1 upon under root 1 minus v square upon c square. This one is correction to the relativistic case. Okay. Now see, come to the point. What is the given condition? We know that your total energy of the relativistic particle is equal to kinetic energy plus rest mass energy. Kinetic energy plus rest mass energy. Okay. Then what is the kinetic energy? Kinetic energy T is equal to rest mass energy minus m0 c square. M0 c square is known as rest mass energy. Okay. Ke plus Re. Okay. Now we can find out the kinetic energy. Take the difference of total energy minus rest mass energy. Got it? First one. Second one. Here total energy is equal to E minus m0 c square, and we can write down the total energy can be written as mc square. Okay. Now this particle is moving in the speed of light. What happened? This mass will be increases. Mass is increases. Mass is related with the energy. Energy also increases. Got it? Next, area also decrease. Mass, time. Okay, so many concepts are there. Okay, but here mass is increases. Okay, mass increase, time decreases, length increase. Okay, now E is equal to m0 c square. Length decreases, not increases. Mass increase is equal to m0 c square. Okay, now shift to this value here. They are given condition. Rest mass, kinetic energy is equal to rest mass energy. Means T is equal to how much? T is equal to rest mass energy. What is the rest mass energy? m0 c square. Yes or no? Rest mass energy is equal to how much? m0 c square. And kinetic energy T is equal to m0 c square. But we can find out what is the kinetic energy formula. Kinetic energy T is equal to E minus m0 c square. Okay, substitute here E minus m0 c square is equal to how much? m0 c square. Yes or no? Now take m0 c square on right side, then this become E is equal to 2 times of m0 c square. E is equal to 2 times of m0 c square. But E can be written as mc square. Okay, write down here mc square is equal to how much? To m0 c square. We have m0 c square. In both sides, which component is common? C square get cancel. Okay, now we are getting the relation m is equal to how much? To m0. M is equal to how much? To m0. Now we can find out the momentum. Momentum means P is equal to m into v. P is equal to m into velocity. Means our aim to find out the mass and velocity. Okay. Mass is equal to how much? Here, mass getting to m0. Why we can write down the into m0 form? Because all answer in the form of m0. Got it? M is equal to 2m0. Second one. We can use another relation. Which relation? M is equal to gamma m0. This is the relation between relativistic mass and rest mass. This is increased by this gamma times of rest mass. And now what is the value of gamma? Gamma is equal to, simply written, 1 upon under root 1 minus v square upon c square. This can be written as m0 upon 1 minus v square upon c square is equal to how much? To m0. These two to get cancel. Okay. Next, 1 upon 1 minus v square minus c square is equal to 2. Or we can take 2 on this side and root 1 minus v square on this side. Now squaring on both sides, then this become 1 by 4 is equal to 1 minus v square upon c square. V square upon c square we can take in this side, then v square upon c square is equal to 1 minus 1 by 4. This is equal to how much? 3 by 4. Then what is the value of v? V is equal to root 3 by 2. V is equal to how much? Root 3 by 2. Generally, we can substitute potential here. Momentum P is equal to how much? ME. P is equal to root mass, root velocity is how much? Root 3 by 2 mc. Root 3 by 2 mc. Yes or no? But no any one option is matches with this answer. Okay. Why? Because here is a root 3 by 2. Here is a 2 extra factor. How to adjust these two? How? Directly we can solve momentum P is equal to this one. We can write down no problem. But all answer in the form of m naught. Means this mass can be written in the form of rest mass. In the form of rest mass. Then P is equal to how much? P is equal to root 3 by 2 of root 3 by 2 of what is the m? M is equal to 2m naught. 2m naught. See, 2 to get cancel. Means momentum P is equal to how much? Root 3m naught. See, 3m naught. See. So many times such type of question asked in SET exam. Okay, root 3 m naught c. Next question. Consider pendulum oscillating in a plane. The kinetic energy of the system in a plane polar coordinate system. Okay, they are given. This will be a fixed support, and this pendulum is moving in a 2D case. You know, we know that here r comma theta is variable. R comma theta is variable. But here this system is a pendulum. This system is a pendulum. Means in this case the length is constant. L is constant. L is constant. Okay. Means here a system is a polar. We know that in polar system two coordinates are variable. Two coordinates are variable. In the direction r is a variable. R is variable in the direction, and theta is variable in the direction. In this direction, length element r and d theta. R and d theta. Okay. This one is a two length elements for this case. Yes or no? In polar system, or r comma theta is a variable component in this case. Okay. Now, see here, simple pendulum, here is the two possibilities. R is a variable and theta is a variable. But here L is constant. L is constant. Then small change in length. Small change in length is equal to how much? 0. Small change in length is equal to 0. Second one, theta also variable in polar coordinates. Plane polar coordinate. Theta also variable. In the direction, theta is a variable. What is the length element? Length L. Radius L. In this case, radius is L. And angle d theta. Angle d theta. Okay. Now we can take the two length elements. First length element dl. Second length element dl2. Okay. But dl1 value 0. dl2 value ld theta. ld theta. Okay. This one is a length element. Then what is the velocity element? Velocity element. This velocity 0. L is constant in the direction. Only theta is variable. And this is L theta dot. L theta dot. Okay. Resultant velocity v square is equal to s 0 square plus L square theta dot square. Got it? L square plus theta dot square. 0 square plus L square theta dot square means simply L square theta dot square. This is the resultant velocity on this bob. On this bob. Got it? Means we know that kinetic energy T is equal to kinetic T is equal to 1/2 m square. 1/2 m square. M is the mass of this bob. M is the mass of this bob. And V is the velocity of this bob. Then what is the resultant velocity? Resultant kinetic energy 1/2 m. Velocity L square theta dot square. This is the kinetic energy for this particle. Here 1/2 ml square is not possible. Okay. Second one mgl cos theta. Mgl cos theta is a one type of energy, but this one is a potential energy. This one is a potential energy. Got it? I mean this also not correct. Dimensionally this one is not correct. A kinetic energy is a dimensionless energy. Okay. This is the dimension of potential energy. Here is the dimension of kinetic energy, no problem, but here theta is a variable. At that time, we can take the radius is equal to how much? 1. Radius is equal to 1, then which kinetic energy is correct one? This one. But here they are given L is the length here. Okay, always memorize here. Length is L. Then what is the kinetic energy for this case? Kinetic energy for this case is equal to 1/2 ml square theta dot square. Always memorize. Here the data is very large, but I will be short it. What is the question? SET question 2013. SET 2013. What is the answer? 1/2 ml square theta dot square. Theta dot square. Got it? There is a dot. Always memorize. This is T. There is not any dot here. Only mgl cos theta. Okay. Next question. SET 2013. The conjugate momentum p theta of a simple pendulum of mass m is suspended from a support by string length L is given by. They ask what is the generalized momentum. Conjugate momentum is a generalized momentum. We can suppose we can write down the Lagrangian 1/2 m. Suppose q1 dot square plus q2 dot square plus q3 dot square and plus so on. Okay, minus some potential energy V, minus some potential energy also function of q1, q2 and so on. Got it? Suppose we consider this one is a Lagrangian L. Now we can find out the generalized momenta. Generalized momenta. And next, in this case, which one is the generalized coordinate? First one, find out the generalized coordinate. Find out the generalized coordinate. Generalized coordinate. Okay. In this case, generalized coordinate. Which coordinate we can say this one is a generalized coordinate? Simply focus on kinetic energy. How many kinetic energies parts is here present? Q1 dot is the kinetic energy part. Next Q2 dot means velocity part. See here initial one, velocity part. Velocity part Q1 dot, Q2 dot, Q3 dot, like that up to Qn, like that. Okay, means in this case generalized coordinate. Means in this case generalized coordinate ZC is equal to S Q1 comma Q2 comma Q3. Means how many velocity component are present in the Lagrangian? Then this number of coordinate is known as generalized coordinate. Okay, always memorize. Suppose this q dot are present in velocity but not present in kinetic energy, then we cannot say this one is a generalized coordinate. Always memorize. This is present in kinetic energy. Then and then only we can say this one is a generalized coordinate. Got it? Means here q1, q2. Suppose we can take here is a qn. Means here q1 to qn are generalized coordinate. Means we can find out the generalized momenta only in this coordinate. We cannot find out suppose qf. We cannot find out the QF generalized momenta because QF is not a generalized coordinate. Means we can find out generalized momenta only for generalized coordinate. What is the definition of generalized momenta? Pi is equal to double upon double qi dot. Pi is equal to double upon double qi dot. Means a partial derivative of Lagrangian with respect to generalized velocity. Partial derivative of Lagrangian with respect to generalized velocity. Partial derivative Lagrangian with respect to generalized velocity is known as generalized momenta. Here is a dot, always memorize. This we can find out the P1, Q1 for Q1 case. Generalized momenta. Means says a PQ is equal to double upon double Q1 dot. For finding the Q2, P2, then we can take the double upon double Q2 dot. Okay. And we can find out the X, generalized momenta for X coordinate. Then double upon double X dot. We can find out the Y. Py is equal to double upon double Y dot and so on. Or suppose we can find out for theta phi. Then P theta is equal to double upon double theta dot. Phi is equal to double upon double phi dot and so on. Okay, got it. Now here system P theta and pendulum. We know that the pendulum Lagrangian L is equal to, already we can solve this one, ml square theta dot square plus mgl cos theta. This is the Lagrangian for simple pendulum. In this case, generalized coordinate means how many velocity component are present here? Only one component is present here. Theta means in this case, theta is a generalized coordinate. Means we can find out the generalized momenta only for theta. This P theta is equal to double upon double theta dot. What is the double? L 1 by 2 ml square theta dot mgl cos theta. Okay, m 1 by 2 ml square. And what is the theta dot square derivative? Theta dot square derivative is how much? 2 theta. And what is mgl cos theta? Here cos theta is not a function of theta dot. This is the function of theta only. Means for theta dot, cos theta is constant. Cos theta constant derivative 0. These two to get cancel. Means P theta is equal to ml square theta dot. Means what is the generalized coordinate? Generalized momenta for simple pendulum is ml square theta dot. Got it? Ml square theta dot. Here they are given ml theta dot. No problem. But here is L power is absent. Here totally power is absent. Here power is on only. Here power is absent. And this dimension is not correct. So which of the following is generalized momenta? Always memorize. First find out the generalized coordinate, means whatever the velocity component are present, we can say this one is a generalized coordinate. Only we can find out the generalized momentum for generalized coordinates only. Here is only one, then we can find out directly. Suppose more than one, like this system is a polar system, then 1 by 2 m r dot square plus r square theta dot square. At that time we can find out the p theta as well as p pi. They ask for finding the theta value, or they ask for what is the value of r or what is the value of theta. Okay, means we can ask two generalized moment also, no problem. Next question, 2017 question. Two blocks of equal masses m are connected by an inextensible massless string of length L, and the block A moves without friction means low loss of energy. The Lagrangian for given system. Okay, now this particle is moving in the direction. Now this is a y distance, then what is the velocity? Velocity in the direction y dot, velocity in y dot. Okay, suppose this also mass is A, because both masses will be same. Then this block is A, this block also we consider as A. This displacement is y, then velocity is y dot. Whatever the velocity y dot, same velocity act on this particle also. Velocity on this particle also. Okay. So what is the kinetic energy of first particle? Kinetic energy T1 is equal to how much? 1 by 2 m y dot square. What is the kinetic energy of second particle? Suppose first particle, second particle kinetic energy 1 by 2 m y dot square. Why both velocity we can take the same? Because here masses is the same. Mass is same, displacement also same. Whatever the displacement of first particle, same displacement in second also. Okay, means total kinetic energy is equal to, yes, 1 by 2 m y dot square plus 1 by 2 m y dot square is equal to 1 half plus 1 half, 1 means my dot square. This is the T total. Okay, this is the T total. Next, potential energy. This particle moving in a horizontal direction. Then potential, height difference 0 means potential V1 0, V2 is depends upon only this particle. Okay, this particle, how much displaced particle? X amount of, yes or no? But how to find out the x value? Y minus mg y minus x. Got it? This one is a potential energy. Then total is equal to Lagrangian. L is equal to, yes, kinetic T minus V. What is the kinetic energy? 1 by 2 get cancel. My dot square and minus mg y minus x. Got it? What is the kinetic energy for this particle? 1 by 2 my dot square. What is the kinetic energy of this particle? 1 by 2 my dot square. Okay, addition of this one, we are getting simply my dot square. This is the total kinetic energy of these two masses. Next, potential energy. This height difference is 0, means potential energy is 0. Whatever the potential energy survive in question because of second particle. This is equal to how much? V2, total length minus x displacement, x plus below the height. Okay, and this will become a Lagrangian for this case. Which option is correct one? Here also my dot square, but height is not y. X also related with this one. Suppose particle is here, this particle is here, then for height we can take y, no problem. But this slightly, this particle shifting in the direction, means here in potential energy x also important. Got it? Hence write down the option number, which one is correct. Means which option are correlated to each other? Two options, first and last. But what is the small difference here? Here x and y, some relation. Here they are given only y. Okay. Means which option is correct in this case? My dot square minus mgy minus x. Next question, set 2013. The momentum of inertia I of a rigid rod of length L. Suppose you can take L of your small l, no problem. About an axis passing through one end of its axis. Okay. What is the answer here? Answer number 1, ml square by 3. B option, 1 by 2 ml square, 1 by 12 ml square. Next, 1 by 4 ml square. Next option, D option is 4 by 3 ml square. Okay. Now, always memorize. We can find out the moment of inertia for any mass or any shape of the body. Always memorize some basic thing. Okay. And now we can say this one is a rod having the length is equal to how much L. Okay. Now this L. Okay. This one is L. Okay. In this L, mass of the rod is, suppose we consider capital M. Capital M is the mass of this total rod mass M. Okay. This M amount of mass enclosed by how much length? L amount of length. Enclosed by L. Okay. Means M amount of mass enclosed by L length. Okay. Next. Slightly adjustment. M mass enclosed by L length. Then 1 unit. 1 unit M upon L. 1 upon L. Yes or no? Means we can divide both sides by 1. Both divide by L. This L will get cancelled. 1 is equal to M upon L. Okay. Construction. Got it? Means in 1 unit we getting M upon L. Yes or no? Total mass by L. 1. Okay. Next. Next small. We consider the small mass dm. Small mass dm. Okay. This small m mass enclosed in how much length? Suppose this distance is a length. Okay. Next small distance. Small change dx. Small change dx. Okay. Same trick apply here also. dm mass enclosed by how much distance? Dx distance. Yes or no? How much distance? Dx. M enclosed by capital L. Dm enclosed by small dx. Okay. Next. Dm is equal to, we can write down suppose 1 into dx. Any change is here? No, because 1 into something is something quantity, that's it. Dm is equal to 1 into dx. But we know that what is the value of 1? 1 is equal to m upon l. 1 upon m. Means dm is equal to 1 is capital M upon L into dx. Capital M upon L into dx. Got it? This construction you can solve by any problem. Use this trick for uniform mass distribution. Here, uniform mass distribution. Nothing is mentioned by default. This one is a uniform mass distribution. Got it? dm. Okay. And we know that moment of inertia. Here we can find out the moment of inertia is the smaller one. Dm into r perpendicular square. Dm into r perpendicular square. Got it? Here r perpendicular distance means angle between them. This distance is 90. Here perpendicular distance means this mass element, small mass element placed from at this axis is how much distance? X distance. Yes or no? X distance. In this case, x is a perpendicular distance. X is a perpendicular distance. Okay. Means di is equal to dm into r perpendicular. R perpendicular is equal to how much? X square. Got it? This one is a perpendicular distance. Got it? This angle between them is 90. This one is a perpendicular distance. X square. Substitute 1 by 1 value. Di is equal to m upon L into dx into x square. Okay. Now we can find out the total system moment of inertia. Take integration. Means I is equal to integration di is equal to integration m upon L x square dx. Got it? Now we can take m is common out. L also we can take common out. Then m upon L. Why we can take m and L common out? Because mass is constant. L also constant. This is a uniform mass distribution. Okay. Integration x square dx. X varying from this point to this point. Got it? Means here initial point x is equal to 0. Here x is equal to 0. Here x is equal to how much? L. X is equal to 0 and x is equal to L. Lower limit 0. Higher limit L. And with the x square integration x to the power 3 means I is equal to ml x to the power 3 upon 3 limit 0 to L. Substitute this value m upon L cube upon 3 1 L get cancel. Means what is the moment of inertia at one end? At one end is equal to ml square upon 3. Means which option is correct? ml square upon 3 is correct one. Got it? This is at one end. This one is at one end. Okay. What is the moment of inertia at the center? At that time we getting answer is equal to ml square by 12. Means which moment of inertia is larger? At one end or at the center? At one end. Because moment of inertia does not depend upon only mass. It depends upon mass and its distribution also. Here rod will be same, but moment of inertia point to point will be changed. At one end, moment of inertia is ml square by 3. At a middle, moment of inertia is ml square by 12. Means at one end, moment of inertia is larger as compared to the center of this system. Next question. A planet has elliptical orbit with the sun at the foci as shown in the figure. Which position of the orbit planet has highest speed? At which point planet have highest speed? Highest speed. Okay. We know that the 3 Kepler's law, all orbits, all planets are moving around the center at foci. Sun at a foci. Okay. And the second, what is the second Kepler's law? Second Kepler's law say that each planet swept equal area in equal interval of time. Equal area in equal interval of time. Okay. Now suppose here we consider particle at a point here as 2 p.m. Okay, 2 p.m. And now this particle reach at this point at 4 p.m. Okay. They acquired, suppose how much area? Suppose they acquired the 100 meter square area. Like that. Okay, 100 meter square area. And which time? 2 to 4 time. Means in 2 hours. Okay. Now particle is here. Particle is here. At suppose 6 p.m. 6 p.m. And next we need to take what is the area at 8 p.m. Okay, 6 to 8. At that time, system is like that. At that time, system is like that. In this case, why this area is covered here? Because both area must be same. Both area must be same in an equal interval of time. Equal interval of time. Yes or no? Here distance is larger. Here distance is larger. It means this planet moving a small distance equal larger area. Equal larger area. Yes or no? But here suppose this particle moving at slow speed, then area also covered in equal interval time is less. Yes or no? Simple सी बात है. यहाँ distance ज़्यादा है, उस length is larger. This distance covered smaller, no problem. Then area getting larger one. But here this particle moving slowly and time going same, but area is not covered equal. ऐसा ना हमें क्या है कि इक्वल इंटरवल में इक्वल एरिया कवर होना चाहिए. ऐसा ना दिस वन इज द सेकंड लॉ. मतलब हमारा डिस्टेंस ये जितना भी लॉन्ग होगा इतनी वेलोसिटी पार्टिकल की कैसे रहेगी? कम रहेगी. ऐसा ना पार्टिकल इज स्मॉलर as compared to this one, but particle reach here at that time we need equal area. Hence this particle is moving very fastly. Got it? Means here speed is less. Next speed slightly increase. Here speed is maximum. Again speed is down. Last least is here. Got it? Why this thing is happen? Here speed is smaller, here speed is larger, because they covered equal area in swept out equal area in equal interval of time. Yes or no? मतलब हमें जो भी एरिया मिला है 2 to 4 pm में सेम एरिया 6 to 8 में भी मिलना चाहिए. Yes or no? और ये जो डिस्टेंस है कम है, इसलिए वो डिस्टेंस बढ़ाना पड़ेगा. समझ में आ गया? इसलिए दिस पार्टिकल मूविंग द highest speed as compared to ABC points. Next problem. If the Lagrangian of a system, Lagrangian is function of rho dot, rho comma theta comma or phi comma rho dot comma theta dot. Theta is taking here rho theta rho dot comma theta dot. Okay, is equal to m by 2 rho square theta dot square plus rho dot square plus rho dot square cosec square alpha minus mgp cot alpha. Okay, and then conserved quantity. We need to find out what is the conserved quantity. Conserved quantity means constant quantity. Here Lagrangian is a function of rho comma theta. Yes or no? Rho comma theta rho dot comma theta dot. Yes or no? In this case Lagrangian contain how many velocities? 2 velocities, which come point down on rho dot and theta dot. Rho dot and theta dot means in this case rho and theta are generalized coordinate. Got it? Generalized coordinate. Okay. First, always memorize whatever we can say. Always for generalized coordinate, not for other coordinates. Here alpha also one coordinate, but don't talk about anything for this alpha part. Alpha notation. Only talk about p and theta, p and rho and theta. That's it. Why? Because this one is a generalized coordinate. Which coordinate we can say this one is a generalized? This velocity component are present in this equation, then this coordinate is known as generalized coordinate. Got it? Means in this case, P and theta, rho and theta are generalized coordinate. Rho and theta means here rho dot and theta dot are velocity. In this case, velocity are present. In this case, velocity are present. Okay. Then rho and theta are generalized coordinate. Okay. In this case, always memorize cyclic coordinate. Which of the following is a cyclic coordinate? Cyclic coordinate or ignorable coordinate. Cyclic coordinate or ignorable coordinate means which coordinate? Missing coordinate. Got it? Missing coordinate. Which coordinate are cyclic? For this coordinate, we getting this conserved quantity. See here, 1 m by 2 rho square rho dot square plus rho dot square cosec square alpha minus mg cot alpha minus mgp rho cot alpha. Got it? Means here, which one is generalized coordinate? Rho and theta is a generalized coordinate. Means we can find out the p theta and p rho. Yes or no? Next, we know that the Lagrangian equation of motion d upon dt double upon qi dot minus double upon qi is equal to how much? 0. Okay. Now suppose this system is coordinate is cyclic. Then coordinate is cyclic. Double upon qi is equal to how much? 0. Double upon qi is equal to 0. Means only getting d upon dt. And this one is double upon qi dot is nothing but generalized momentum pi is equal to how much? 0. Any quantity is derivative is equal to 0. I mean this one is a constant. Yes or no? Means pi is equal to how much? C. Pi is equal to C or conserved quantity. Got it? General things. Now here generalized coordinate p and theta. Rho and theta is a generalized coordinate. In this case, which component is missing? Here is a theta dot. Here is a rho dot. But here is a rho is present, but theta dot is not present. Means in this case, theta is a cyclic coordinate. Got it? This one is a cyclic coordinate, ignorable coordinate. Then double upon theta is equal to how much? 0. Double upon theta is equal to 0. Then what is the value of p theta dot? No need to write down because only we can say which of the following component is conserved. Means d upon dt double upon theta dot minus double upon theta is equal to how much? 0. Got it? D upon dt double upon theta dot minus double upon theta is equal to how much? 0. But theta is a cyclic coordinate, then double upon theta is equal to simply 0. Only focus on this part. D upon dt. Okay. And double upon theta dot is equal to how much? 0. But you know that p theta is equal to double upon theta dot. Means d upon dt p theta is equal to how much? 0. Means in this case, which component is the conserved quantity? Any quantity is derivative is equal to 0. Means this one is a constant. Means in this case, which component is conserved? P pi is conserved. Or sometimes they ask what is the conserved quantity. At that time they are given the values. We can take the p pi. P pi means double upon rho dot. Means we can take a rho dot square. Derivative is how much? 2 rho dot. 2 get cancelled. Means what is the conservative function? M rho dot cosec square alpha. Means which of the following quantity is conserved? Sometimes they are given p theta, p phi or p r, p rho like that. But sometimes they are given directly values. Okay. Means we can find out in this case p rho, p theta value. P theta value is equal to how much? M rho square theta dot. Okay. This one is a conserved quantity. They ask sometimes what is the conserved quantity? M rho square theta dot is a conserved quantity. Or we can say p theta is a conserved quantity in this equation. Next problem. Example of a non-central force is, this also 2011 question. 2011 set question. Okay. Example of non-central force is gravitational force, Coulomb force, Hooke's law, and dipole-dipole interaction. Okay. Out of this four, we know that two forces are definitely central force. Central force means this force is guided by distance, guided by radial part. Guided by radial part. Yes or no? Means in this case, radial part R is important. Okay. And such type of this two particles joining with a distance R, and force is related with this one. Then we can say this one is a central force. Means central force is a function of R only. Central force is a function of R only. Okay. And this is known as a central force. Okay. And central force, we know that gravitational force also central force. Coulomb force also central force. We can study the central force at that time. Focus on this two forces. But next, Hooke's law also satisfy the central force. Central force. Okay. Means out of four, this one is a correct option. Except this one. This one is not a central force. Always memorize. Some few confusion in Hooke's law. Okay. When we can see this question, definitely these two options have no problem. But comparing with these two options, this one is a central force. Next question. Masses M and 3M, 2011 question. Masses M and 3M are attached to the two ends of a spring constant K. It's a period of oscillation. Okay. Now here we consider the two masses. This will be M, and second mass is 3M. Okay. Having the constant K, having the spring constant K. Now this particle moving in the direction velocity x dot. This particle moving in the direction velocity x2 dot. Because here both masses will be different, velocity also different. Then what is the kinetic energy? T is equal to 1 by 2 m x dot square plus 1 by 2 3m x2 dot square. And what is the potential energy? Final minus initial distance 1 by 2 k x2 minus x1 bracket square. x2 minus x1 bracket square means simply 1 by 2 k x1 square plus x2 square minus x1 x2 minus x2 x1. Got it? This is the potential energy. How to find out the frequency? First find out the frequency using the kinetic energy matrix x1 dot x2 dot, and similarly x1 dot x2 dot. What is the coefficient? Here m, here 3m. And what is the potential energy matrix? x1 x2 x1 x2. Okay, here is a k minus k plus k. Okay, substitute this value here, then we get a kinetic energy and potential energy matrix. Means a T matrix m0 0 3m. Okay, and what is the potential matrix? K minus k k. Okay, this one is the potential matrix. Using the secular equation, V minus omega square T is equal to how much? 0. From this equation we are getting two frequencies. Here two masses, we are getting two frequency. Three masses, we are getting three frequency. Omega 1, x1 and x2. And they ask you what is this omega frequency. Okay. Now, but here always memorize, system is not attached with some support. Then one of the particle have the zero frequency for reference. Means in this case one frequency is equal to 0. We need to find out only one frequency. Got it? This one is a regular method. But for set question, for set point of view, this is not applicable method. Why? Because this one is a very time consuming process. Hence we cannot use. We can use the direct method. W is equal to, yes, W is equal to, write down M1 plus M2. M1 plus M2 okay, upon M1 plus M1 into M2. M1 into M2. This one is a W formula. W is equal to M1 M2 K upon M1 M2. And now substitute the M1 M2 value. M1 M2 M plus 3M 4M. This is equal to 4K upon M1 M2 M square 3M square. Okay, 1M get cancel. Means omega is equal to getting how much? Omega is equal to, yes, omega is equal to 4K upon M. 4K upon 3M. Okay, and T is equal to how much? T is equal to 2 pi upon omega. T is equal to 2 pi by omega. Okay, means T is equal to 2 pi by omega. Yes, omega is equal to how much? T or 2 pi. So this will become a reverse. 3k upon 4m. 3k upon 4m. 4 take common out. These 2 and 4 get cancelled. And this is equal to pi under root 3k upon m. Under root 3k upon m. Or simply, we cannot memorize this method. Directly we can take. We know that k is equal to how much? M omega square. M omega square. Then omega is equal to how much? Under root k upon m. Under root k upon m. Okay. Here we can take the two masses. How to two body problem converted into single body problem using the reduced mass concept. 1 by m is equal to 1 upon m1 plus 1 upon m2. Okay. Means 1 upon m is equal to m1 plus m2 upon m1 into m2. M1 into m2. Substitute this value, then omega become root m1 plus m2 bracket complete k upon m1 m2. Means we can find out the omega value. Substitute t is equal to pi by omega, getting the answer. Which of the following option is correct? And this is a very important here. 4 we can take common out. 4 become 2. 2 to get cancel. Pi root 3k upon root 3k upon. Means in this case, which option is correct? D option is correct for this case. Next, 2011 question. The mutual potential energy V of two particles depends on their mutual distance R as follows. V is equal to A upon R square minus B upon R, where A is greater than 0 and B is greater than 0 are constant. For what separation R are the particle in static equilibrium? Static equilibrium. Okay. See here is the nature is like that. Potential is nature is like that. Here, potential is a maximum. This one is unstable, but first derivative is equal to 0. Here also, this one is the more stable. Any quantity is maximum or minimum or stability. Maximum stable or maximum unstable. First derivative is equal to how much? 0. Means point A, first derivative 0. At point B, first derivative 0. At point C, first derivative is equal to how much? 0. And they ask static equilibrium. Okay, means equilibrium condition. First derivative is equal to how much? 0. Means here is a dV upon dr is equal to 0 at r is equal to how much? R0. R is equal to R0. Got it? Means R0 the distance, this will be stable equilibrium. Okay. dV upon dr is equal to, yes, derivative minus 2 upon r to the power 3 minus become plus b upon r square is equal to how much? 0. At what distance? R is equal to R0. Okay. Then this is equal to how much? Minus 2a upon R0 cube is equal to b upon R0 square. B upon R0 square. Okay, the square get cancelled. Both sides multiplied by minus 1, then this become plus. Means R0 is equal to 2a upon b. R0 is equal to how much? 2a upon b. Here they can use the notation R. Okay, means R is equal to 2a upon b. Means at this distance, this system become equilibrium. So many times in a set exam they ask such type of questions. Next question, 2015 question. 2015. Okay, for a given system Hamiltonian, h of q comma p is defined as f of h of q comma p is equal to this one. Which of the following option is correct? Okay, always memorize the Hamiltonian equation. Hamiltonian equations. Hamiltonian equation. Two equation always memorize. Q dot is equal to da by h upon da by p. Q dot is equal to da by h upon da by p. And second Hamiltonian equation, P dot is equal to minus da by h upon da by q. Da by h upon q. Okay. P dot minus sign. Always memorize. P dot minus sign. Next, find out the Q dot. Q dot is equal to da by h upon da by p. Q dot is equal to da by h upon da by p. P derivative 1. Okay. Plus 1 minus p square derivative means 1 upon 2 root 1 minus p square, and derivative of p is how much? 2p into sin q. These two to get cancelled. Means simply 1 plus p sin q upon root 1 minus p square. This is the Q dot. Okay. And which option? This is equal to this one. Q dot is equal to S. Q dot is equal to Q dot is equal to yes. But here is no any option is plus. Okay, yes or no? Means some mistake is there. Yes or no? Which mistake? You take the derivative of 1 minus p square. 1 minus p square derivative is how much? Minus 2p. Minus 2p means here minus sign will become. Yes or no? 1 derivative is a 0, but p square derivative is a minus 2p. Minus become plus. Next, minus we can take RHS because here minus is left side. Minus p means minus p dot is equal to W h upon W q. P with respect to q 0 plus 1 minus p square. 1 minus p square constant, and sin q derivative is how much? Cos q. Sin q derivative is equal to how much? Minus q. But always memorize in this case two formulas. Q dot is equal to W h upon W p, and p dot is equal to minus W h upon W q. Next problem. Which of the following properties of the Lagrangian is due to Pace's isotropic characteristics? Pace's isotropic characteristics in inertial frame of reference. In inertial frame of reference. Already I will say that in which quantum mechanics at that time invariant to translation means in a linear case system is a homogeneous means this is related with the pace is homogeneous. Translation here three quantity. Which of the following properties of the Lagrangian is due to Pace's isotropic characteristics? Inertial frame of reference. In inertial frame of reference. Okay. Now here invariant to the translation. Invariant to the translation means the pace is homogeneous. Pace is homogeneous. Okay. Next, invariant to time. Invariant to time means energy is conserved. Energy is conserved. Okay. And third one, isotropic pace means invariant of rotation. Invariant of rotation means which option is correct here? Third option is correct one. Got it? Translation, pace homogeneous. Rotation, isotropic pace. Got it? Invariant to time, energy is conserved. For free particle under the action of central force. Under the central force. Which of the following quantities is conserved? Which of the following quantities is conserved? Okay, here we can take the tau. Tau is equal to how much? W bar upon W t. Okay, but here torque acting on the body in central force is equal to how much? 0. Torque is equal to 0 means W upon W t is equal to how much? 0. Means implies that in this case L is conserved. L is conserved or constant. Means in this case which quantity is conserved? Not a linear velocity, not angular velocity. This is in this case linear momentum is conserved. In this case linear momentum is conserved. Why this is conserved? Because in this case torque is equal to 0, and we know that torque is equal to W upon W t. Torque 0, W upon W t is equal to 0 implies that L is constant. L is constant.